Alright, so we have the 3.5 notes here. Transformations of quadratic functions. Now I had to rewrite a lot of these by hand because my printer is just not printing. As you can see, this is what the back looks like. My printer needs a lot of new toner, and so I rewrote these just so that they're a little bit clearer to see. Additionally, I am recovering from a pretty nasty cold, so that's why I'm not there today. And if you hear me coughing, that's why. Okay, so let's get started by talking about the parameters of a quadratic function. So just like last time we had parameters m and b for linear functions, this time this is the general form of a quadratic function, and we have a, h, and k, and these are called parameters. By altering them, we can transform a quadratic function. So just like last time, we have a bunch of different transformations that we can apply. The three big ones are dilations, translations, and reflections. So I'm going to scroll down here. Again, you can pause the video, rewind, fast forward, change the speed of it. I believe Canvas allows you to go up to double speed. You can do whatever you would like, and you can also rewatch this video at home if you would like. So this video should just cover the front page. There will be a separate video for the back. And yeah, let's get on with it. So, dilation. Dilation has two forms. There are two types of dilations. The first one is a stretch. So this is where the parabola gets skinnier. Alright? This is where the parabola gets skinnier. This is caused by the absolute value of a being greater than 1. So if the absolute value of a is greater than 1, so things like 2, 4, and then anything smaller than 1 in the negative direction, so like -3, -5, basically plus minus anything bigger than 1 is going to cause a stretch. And the parabola gets skinnier. Now compression is where the parabola gets wider. And this is caused by the absolute value of a being less than 1. Things like 1/2, 1/4, 2/3, things that are less than 1 or between 0 and -1 in the negative direction, so like -1/2, -1/4, -1/5, things like that. Those are what cause compressions. Okay, and this is where the parabola gets wider. Okay, a translation left or right. The parabola itself is going to stay the same, but the entire graph is going to shift left or right. So, a translation left or right is caused by h being something else besides 0. So when h is not equal to 0, that causes a shift left or right. So when you have x plus h in parentheses, that implies a left transformation or a left translation, and when you have x minus h, that implies a right translation. No, I did not get those backwards. That is the correct order. For my two students who are in both AFDA and Algebra 2, you will know why this is the case. Alright, now for translation up and down, this is caused by k being something other than 0. So, when you have a plus k at the end, this implies an up translation, and minus k at the end implies a downward translation. Okay, and now for reflections. We only deal with reflections across the x-axis in AFDA, so we're going to talk about this. When a is negative, So when a is negative, or when a is less than 0, this causes a reflection over the x-axis. Sorry. And it causes the entire parabola to flip upside down. Kind of like that. Alright. So that's going to be it for this particular video, because that's all there is for this front page. And click on the other video for the back page.